Hyperbolas are kind of like parabolas, but times 2. You get one parabola over here being like, oh, I'm doing my thing, and then you get another parabola over here doing its thing. Then you put them together opposite of each other, and boom, you've got a hyperbola. So there's a few things to consider when looking at hyperbolas, the first of which is our center, which you might guess by now is going to be the opposite of x term and the opposite of the y term, or hk. That's just a point right in between two of our parabolas forming the hyperbola. You're also going to want to pay attention to which term comes first, either the x squared term minus the y squared term or the y squared term minus the x squared term. That's going to determine whether each side of the hyperbola is opening up horizontally or vertically. The vertices of the hyperbola are located as the main point where each side of the hyperbola is extending. Those are either going to be a distance of a horizontally from the center point or the distance of a vertically from the center point, depending on your equation. To find your foci, we're going to use the fancy ABC relationship we have down here, which you should think very similar to Pythagorean theorem, c squared equals a squared plus b squared, and the foci are going to be a distance of c away from the center point, again, either horizontal or vertical, depending on that x squared term or y squared term. Lastly, whenever graphing hyperbolas, we want to find the equation of two lines as asymptotes to help guide us when we're sketching our graph. You can find these equations by using your center, hk, along with your a and b values. You're going to get y minus k equals plus or minus b over a, x minus h, or y minus k equals plus or minus a over b, x minus h. Now, you'll see that in one scenario you use b over a, and the other scenario you use a over b. I always remember rise over run. Rise is my y value, run is my x value, and I know rise over run is the slope of a line. So you'll see over here, my rise over run is b over a. In this case, when you have a y squared term, my rise over run is a over b. So it's always whatever denominator you have for the y term over the denominator you have for the x term for your slopes. Here, let's go ahead and graph the equation y squared over 9 minus x squared over 25 equals 1. We see this is a hyperbola because it's got the y squared term minus the x squared term all equal to 1. Why don't we start at the beginning? Always a fantastic place to start. To find our center, we need to find the opposite of our x term and the opposite of our y term. Since these aren't grouped with anything, we're just going to get 0, 0. And there we are, point right at 0, 0. Next up, vertices. We need to find the square root of this first denominator term right here. Square root of 9 gives us an a value of 3. Since our y squared term is first, we know this is going to be a distance 3 vertically up and down, again, because the y squared term is first. So let's count that. 1, 2, 3, 1, 2, 3. And we've got our vertices at 0.03 and 0, negative 3. To find our foci, let's go ahead and do c squared equals a squared plus b squared. That's going to be 9 plus 25, or c equals the square root of 34, and let's round that out. It's going to be much easier to graph. Using some quick calculator magic, we're going to get c equals 5.83, and that's going to be in the same direction as our vertices, so we'll go up 5.83 and down 5.83. And there we have it, foci points at 0, 5.83, and 0, negative 5.83. Last up, asymptotes. We can use our standard equation of a line, y minus k equals plus or minus a over b in this case, or rise over run, x minus h. Since our h and k are 0, that's going to leave us just with y equals plus or minus something x, and that something is our slope, or our a over b, or our rise over run, the denominator square root under y, and the square root of the denominator under x, or 3 over 5. So our asymptotes are going to be at y equals plus or minus 3/5 x. We've already got a starting point right here at the origin. We can use our slope, both positive and negative, from here. That's going to first be up, 1, 2, 3, rise over run, 1, 2, 3, 4, 5. To balance it out, I'm just going to go in the opposite direction as well. 1, 2, 3, 1, 2, 3, 4, 5 to get another point. And there we have one asymptote. I'll go ahead and draw that in. And to do our other one, let's take the opposite slope, so negative 3/5. We can go down 3 over 5. And to balance this out, let's go in the other direction, up 3 to the left 5. And let's draw our asymptote right in there. Beautiful. Now we can draw our hyperbola. Just make sure that it follows each asymptote and goes through each vertice like so. And we've graphed our first hyperbola. Wonderful. Gold star, if you know what that means. All right. X plus 2 squared over 12 minus y plus 1 squared over 18 equals 1. Starting with our center, we got the opposite of our x, the opposite of our y term, negative 2, 1. Boom, right there on the graph. To find our vertices, we need the square root of our a term, or this 12, a equals square root of 12, approximately 3.46. Since x squared term is first, this time we're going to be going in the horizontal direction. So I can just start from my center and go over 1, 2, 3.46, and to the left, 1, 2, 3.46. There we're going to get our points at 1.46, negative 1, and negative 5.46, negative 1. Just adding this value in the horizontal direction to our x coordinate, negative 2. Next up, our foci. Using our c squared equals a squared plus b squared, we'll get c equals the square root of 12 plus 18, or the square root of 30, which is approximately 5.48. And from there, we're going to go again in the horizontal direction because we have that x squared term first. 1, 2, 3, 4, 5.48. And in the left, 1, 2, 3, 4, 5.48. And we've got our foci at the points 3.47, negative 1, and negative 7.48, comma, negative 1, adding and subtracting this 5.48 from our x coordinate. I'm pretty fly for a foci. And for our asymptotes, let's go ahead and use our equation. Y minus k equals plus or minus b over a in this case, or rise over run. X minus h, we do have a center this time. That'll give us y plus 1 equals plus or minus something, our slope, x plus 2, and that something is going to be our b over a, or our square root of our y, our rise, over the square root of our denominator of our x, our run. That'll be square root of 18 over the square root of 12. And there's our slope, square root of 18 over 12. Square root of 12, that's going to be a little difficult to graph, so I'm going to decimal approximate that to about 1.22. So we know we have a point right here at our center, negative 2, negative 1. Our slope is going to be plus or minus 1.22. We can put that 1.22 over 1. And let's go ahead and graph that. So we'll go up 1.22 and over 1. And to balance it out, let's go down 1.22 over 1. That'll give us one asymptote we can graph. And again, this just needs to be approximate to give us a basic shape of our graph. Going in the opposite direction, we'll go down 1.22 over 1. Then we'll go up 1.22 to the left 1. Let's go ahead and draw in that asymptote right there. And we're ready to graph our hyperbola. Remember, the hyperbola goes along the asymptote and through each vertice. Along the asymptote, through each vertice, and we've got a lovely hyperbola. I love math.